us continue with finding area of more quadrilaterals. We are going to look at area of a rhombus. Area of a rhombus. How does a rhombus look like? You can sketch it here. So opposite sides are parallel. And all the sides in a rhombus are equal. We now look at area of a rhombus. In a rhombus, opposite sides are parallel. And all the four sides are equal. Suppose we have, we can label our rhombus A, B, C, and D. If we introduced a diagonal here, a diagonal there, introduce a diagonal here, and this other one here, there, we can see that diagonal BD is longer. It's longer than AC. So we need to put down some properties here. When the two diagonals meet, they meet perpendicularly at 90 degrees. They meet perpendicularly. That is number one. Diagonals of a rhombus intersect perpendicularly. They intersect perpendicularly. That is property number one. Property number two. When diagonals of a rhombus intersect, they bisect each other. They divide each other into two equal parts. So once they intersect, this diagonal here is divided into two equal parts. This other one here is divided into two equal parts. So the second point is that diagonals of a rhombus bisect each other. Good. With those two properties now, Lana, we can now look at an example of how to find area of a rhombus. The figure below is a rhombus. AC, this diagonal here, is 12 centimeters, and BD is 20 centimeters. The longer diagonal is 20 centimeters. Then you should find the area. So you come and fix the two properties of a rhombus. One, when the two diagonals intersect, they intersect perpendicularly. So show that they intersect perpendicularly. Okay? From there, we go to the second property. Diagonals of a rhombus bisect each other as they intersect. Diagonals of a rhombus bisect. They bisect each other. They divide each other into two equal parts. So this part is equal to that, and this part is equal to that. So BD was 20, and therefore divide by 2, this will be 10 centimeters, and this will be 10 centimeters. We come to this other diagonal. It was 12, and therefore 12 divided by 2, this here will be 6 centimeters, and this also will be 6 centimeters. Is it visible? 6 centimeters. And therefore, learner, how do we find the area? So, to find the area, you can consider triangle ABD and also BCD. These two triangles, this one and this one, are equal. This triangle here and this other one are equal. So it is a matter of getting area of one triangle, then you multiply by 2. So let us get area of triangle. Area of triangle. Area of triangle ABD. Area of triangle ABD. Area of a triangle ABD is equals to what? So its area will be equal to what? A half times its base. This is its base. This is the base, which is 20, and the height is 6. So area of triangle ABD is a half times base, which is 20, times the height, which is 6. Good. So from there, you can divide by 2, get that. You multiply 10 times 6, you get 60 centimeters square. That is area of this upper triangle here. And therefore, learner, the area of our rhombus, area of the rhombus, therefore, will be equal to 60 times 2. 60 times 2. And therefore, this gives us 120 centimeters square. 120 centimeters square. So let us now look at area of a kite. Area of a kite. Suppose you are given a kite. So let us look at how to find area of a kite. Area of a kite. We have the figure there. So how do you find area of this kite? To find the area of this kite, we know that this side of the kite is equal to that. As you can see, it is 8 centimeters. This other one is equal to this one there. So how do you find the area? You come and introduce a line here so that you divide the kite. So that you divide the kite into 2 parts. Into 2 parts like that. Call this triangle A and this B. And therefore, to get the area of this kite, you just need to find the area for triangle A, area for triangle B, and then you add. Therefore, area of triangle A. Let us find area of triangle A. Area of triangle A. So area of a triangle A is what? You can see we are given 2 sides and an included angle. 2 sides and included angle. And therefore you use the formula a half times 8 times 8 sine 35. Area of a triangle given 2 sides and an included angle. It's a half times this side sine of that. So you move on by this 1, by this 4, and therefore you are talking of 32 sine 35. 32 sine 35 degrees will give you what? You use a calculator, you should get 18.35 centimeters square. That is the area of triangle A. We now get the area of triangle B. Area of triangle B. We use the same formula. A half times this side sine 60, because again you are given the 2 sides and an included angle. And therefore area of this will be equal to a half, times this side, 6, times the other side, 6, sine 60 degrees. Sine 60 degrees. You can cancel out by 2, 1 by 2, 3. So you'll talk of 3 times 6 is 18 sine 60 degrees. 18 sine 60 degrees. You use a calculator. You use a calculator. If you use a calculator, you should get 15.59 centimeters square. After finding those two, the area of those two triangles, you then add to get the area of the kite. Therefore, Lana, area of a kite, will be equal to what? Area of triangle A plus area of triangle B, 15.59. So you add this, you add it accurately, you get 3. So that 3.94 centimeters square is the area of our kite. And therefore, with that, Lana, go and do more practice on how to find area of a rhombus and also area of a kite. Thank you.